Vortex se puede decir que nació en el año 2002, cuando descubrí en internet un vídeo en el que un puente, el puente Tocoman-Narrows, colapsaba, se derrumbaba, por un efecto de resonancia que yo no conocía en aquel momento, con los propios remolinos que él generaba. Todos hemos visto cómo una bandera oscila, ¿no? Se mueve, ondea, gracias a los remolinos que ella con su tela genera y también el propio mástil que la sujeta genera, ¿no? En ese momento pensé, bueno, podríamos diseñar un aparato que nos permita coger energía del viento que sea todavía más sencillo para que el efecto se produzca de manera óptima, ¿no? Al maximizar el efecto. Nuestra estructura trata de apoyarse en esos remolinos para empezar a oscilar. Hay una resonancia, hay una coincidencia de frecuencias, la frecuencia a la que aparecen esos remolinos, la frecuencia a la que oscila nuestra estructura. Cuando son la misma, el equipo empieza a oscilar. Cuando ya estamos oscilando y tenemos energía mecánica, ya hemos absorbido energía del viento, lo que hacemos es convertirlo en energía eléctrica.
So here we have an unconventional wind turbine that is going to revolutionize the energy industry. This one I have to give some credit for actually being more than just a rehash of old and mostly abandoned tech. Vortex Bladeless is attempting to produce a wind turbine that isn't actually a turbine. So how is it supposed to work? Well, it's actually kind of a neat idea. This lightweight, flexible stick gets blown by the wind. Aeroelasticity causes the stick to sway, and this movement is used to create electricity. Cool! The world's energy problem solved by sticks getting stuck in the ground.
Las ventajas de Vortex son fundamentalmente económicas. Al tratarse de un sistema tan sencillo, los costes de fabricación y de operación del equipo están en torno a la mitad. Adicionalmente están las ventajas desde el punto de vista medioambiental. No vamos a hacer ningún ruido, no vamos a matar pájaros y el hecho de no tener que incorporar piezas en contacto, como engranajes o rodamientos, nos hace no necesitar ningún tipo de lubricantes, por tanto no tener que gestionar este tipo de residuos.
This thing is amazing. It'll cut production and operations costs in half. It runs completely silently. It won't kill birds, which those pinwheels have quite a penchant to do. It has no gears, no bearings, no parts at all that come in contact with each other, and it needs no lubrication of any kind.
Our future is to work in product. So the first product is going to be 3 meters high, 100 watts, and we will provide it to the people who doesn't have lights, like in India, many places from Africa, joining wind Vortex with solar panel. The next step is going to be for 2016 a 4 kilowatts Vortex that you can put it in your house. It will be 13 meters high. You can be in off-grid or on-grid. And our vision is to build 1 megawatt. It will be over 150 meters. And this is not our league. This is the big industry league. But we know that with this Vortex, we are going to change the wind industry. We are going to change the world.
Vortex Bladeless is going to change the world. Well, maybe not. This video is from their quite successful Indiegogo campaign back in 2015, and you might be asking why I'm even covering this since it's from 2 years ago. Well, I hemmed and hawed on it for a while, but their Twitter feed is still active and they are posting updates on their progress. If you caught the last part of that, they laid out their strategy and development. They were first going to make a 100-watt unit that was due at the end of 2015, then a 4 kilowatt by the end of 2016, and then they're coming after the big boys with a utility-scale 1 megawatt unit. So now that it's early 2017, where are they in their progress? They haven't developed a damn thing. But before we investigate what they have been doing over the past 2 years, let's first look at the money that they raised. Their Indiegogo campaign was surprisingly modest, with only asking for $50,000. This number was smashed and they raked in just over 76 grand. And in all honesty, if they had asked for it, I think they would have easily raised $250,000 or more. But this is not their only source of cash. They also brought in over $1 million from investors and the government in Spain. And that's before they started their American fundraising tour. So with all this cash already on hand, why are they doing an Indiegogo campaign at all? That's because they want a shitload of cash to develop their turbine. How do I know that? Asked the foaming at the mouth environmentalist hunched over his MacBook Pro. Because I found this snippet from their 2014 Spanish startup pitch show.
This year, we raised 1 million from public and private funds to demonstrate what we already did. And we are looking for 15 millions, 15 millions, 15 millions, 15 millions, 15 millions, 15 millions, 15 millions to develop, scale, and start selling of 4 kilowatts in 2 years and 1 megawatt in 3 years.
$50 million. They want 50 million before they can even produce a single turbine. It's actually alluded to in their campaign that Vortex used Indiegogo as an advertising method. They can use a very successful crowdfunding campaign as proof of public interest when soliciting deep pockets. And the pockets they're going after are deep. Now, I don't know how much they were actually able to raise, but I know how much they wanted to. And if companies and governments are as trusting and stupid as the public is, which they are, I bet they got pretty close to their goal. So why does all this even matter? Because their turbine doesn't work. With the notable exception of photovoltaic cells, all generators require 3 things to produce electricity: a magnetic field, a conductor, and movement. Now, since you can only create a magnet of a certain size so powerful, and you can only cram so much conductor into a finite space, the magnetic field and conductor portion of that equation will essentially tell you how big of a generator in physical dimensions you're going to have. So, a small generator can only create so much power, while a very large generator can create anything from a small amount of power to a lot of power. So while the how to build a generator is well known and they are relatively easy to construct, the problem that humanity continues to deal with is the movement variable. It takes a lot of energy to make these things turn, which is why when you look at the biggest generators, they are generally turned by massive amounts of falling water, massive amounts of heat created through burning coal or nuclear fission, or by burning vast quantities of natural gas in jet engines to make these things turn. Even the large wind turbines, when you watch a video of a turbine, the blades look like they turn fairly slowly, but inside that nacelle is a gearbox which takes that slow, high torque movement and speeds it up significantly to turn the generator. So when you hear me talk about the amount of movement that is needed, what do you think is the issue with the Vortex turbine? There's very little movement here. You don't know what you're talking about, Fox. I can see it swinging back and forth just fine. Yeah, I can see it swinging too, at the top. But that's not where the generator is. The generator is supposed to be down here. So all that movement at the top of the turbine doesn't translate to very much movement down where it counts, where the generator is. I noticed in this clip that they took the generator off, and unfortunately this is the longest uncut clip that I have been able to find from them of this thing actually moving in the wind. The only other clip I have with the generator attached here lasts for all of 6 seconds. So here's a close-up of that same shot. Again, very little actual movement at the generator level. Now compare it to this micro hydro plant. According to the owner, this is only a 500 watt plant. And look at the rotation speed of that Archimedes screw. And then we find out these guys don't even use a traditional rotary generator. They use a linear generator. And I'll let them explain.
So, and it's made by magnets. So the philosophy of Vortex is not having any gear, mobile padding contact, any oil, nothing to maintain. So we start to field test. This was for 4 meters size. We thought it wouldn't work because there are many turbulence, and we thought we need laminar fluid. This is our 6 meters field test, and it's also working very well. And this space is really close to Madrid, in Avila. We are working 84% of the time. And the third milestone was to produce energy. So we had 2 ways. The first one was with piezoelectric material. That it's postponed a little bit because the piezoelectric materials now are very low power density, and we are producing new ones for the next 4 years. And the second way that it's working now, it's with a linear alternator. So we are converting this movement, this oscillation, to a linear movement. All of this you see, it's patent. So, and this linear alternator, it doesn't have also gears or mobile padding contacts. So it's like flotating, something like that, with a magnet. So we are doing everything with magnets. So you have this mast. This mast is very light. It's 4 meters from here to here. It's only 3.8 kilos. It's very light, very rigid, made it with the same materials as the blades. And here you have the alternator, and inside you have the magnet system to turn the system to many ranges of velocity of wind.
So going back to our short clip of this thing actually working, do you see that generator moving up and down in a linear motion at all? Because I sure as fuck don't. For this thing to be producing power in the way that they say it would, it should look like it's being furiously masturbated, as the mast slowly rocks back and forth. Over and over again they tell us how successful their prototype is, yet they never give a single piece of information on how much power it produces. By success, I believe they mean that it didn't fall down, and that it actually moves in the wind. But they have not shown any evidence whatsoever that they're actually producing electricity through this method. Yet, despite glaring problems brought up by the most basic of analysis, this thing was featured in Forbes, MIT Technology Review, Wired, and the Daily Mail, as well as the Huffington Post, and had puff pieces produced by ENC Engineering Update and Reuters.
A suspension bridge in the United States stretching and collapsing in high winds in 1940 inspires a silent, swaying new-look wind turbine in Spain today.
I'm sure there's a lot more that I didn't come across. During what looks like their meeting at MIT, they gathered all sorts of testimonials as well.
If you're thinking about...
Okay, now this may be critique videoception, but what the fuck is that? This girl's supposed to be from Harvard, yet she's got in the background some poster made from a middle school science project. Really?
Things like environmental impact, carbon footprint, things that I really feel strongly about. You need to look at how the technology is produced, used, and then disposed of. So for Vortex, you really have only really few parts. It's very light. Most of the stuff you can just produce anywhere, so the transportation cost will be really low. And then you see the traditional wind turbine, for example, that uses a lot of metal and requires a lot of concrete to stabilize this technology. So at the end of the day, this is really a no-brainer. The environmental impact of this technology will be much lower. So that's why I work for Vortex.
I met this team in Boston that told me they were able to produce energy without any blades. Isn't it amazing? On top of it all, they don't kill birds, it's a lot cheaper, and frankly, I think I like the design much better than what's on now. I think my money is definitely on these boys.
The wind industry, we're going to be cutting down costs by 50%. This is huge and disruptive because it means we can compete with fossil fuels, we can compete with natural gas, and we can make wind power a reality, not only in cities, but also in places like India, where millions of people need energy at a really low cost. So I strongly support Vortex, especially as we try to get into places like India and new places like offshore generation.
And even the ASME, the American Society of Mechanical Engineers, wrote an article where they did nothing but parrot the talking points given to them by Vortex Bladeless. Nowhere, anywhere across the internet that I have searched have I been able to find a single place where someone raised as much as a question to these people. It was just repetitive talking points about how great this thing is. Hold on there, recording Fox. This is post-production Fox here, and in cutting screen caps for this video, I actually came across an article where someone dared to challenge the physics of the Vortex Bladeless turbine. And my hat is off to Phil McKenna from MIT Technology Review. Go ahead and check out his article. The link to it will be in the description, along with links to all my other sources for this video. He brings up more issues that I did not even touch on. So now that we looked at their fundraising efforts and their marketing campaign in 2015, where are they now? Well, a look at Vortex Bladeless's website shows that not much has changed. They continue to use all of the same images that they did in their campaign. They have all the same talking points that they did in their campaign. If you look at the two turbines that they're trying to produce, you can see that they dropped the 100-watt model. So now they're only focused on a 4 kilowatt and a 1 megawatt model. But nowhere on their website do they have any sort of dates when either of these will begin to be available. A quick look through their Twitter feed shows that they have received even more funding, this time from the EU, in a bid to increase wind energy by 2020. Seeing as how it's 2017, I don't think Vortex Bladeless is going to be much of a part of the 2020 deadline. So is that all that they have put out in the last 2 years? Of course not. They've also put out this video of a giant green dildo flapping in the wind, all while one of the founders looks very science-y in the background. And this one, what that device is measuring? Who knows, because they don't tell us. Is it actual energy being produced? Is it the rate that it's being flapped back and forth? Is it the power of the fans that are blowing? I don't know. And then the kicker is their latest update on Facebook, dated February 1st of this year. And what are they doing right now? They're working on a 1 meter tall prototype that makes 5 watts. Now what would happen to their 6 meter tall unit? Apparently that one doesn't do jack shit. And even in this post, they concede, yeah, they're only working with 5 watts right now. And still, people are begging to give them money. Look at these replies. 5 watts sounds great. An LED bulb or charging a USB device through the night with your 1 meter generator. I'm good with that. When can I buy one? Congrats! A great project. I'd like to receive a prototype for early adopters. Send a link to make payment. So this got me curious. Can a 5-watt generator charge a USB device? Well, it sure as fuck can't charge my cell phone. My handy little watt meter shows me that it takes 23 watts to charge my cell phone that was at 45% when I plugged it in. So I would need 5 of these things just to charge my cell phone. In fact, even my hands-free Bluetooth earpiece requires 3 watts to charge. Their current prototype would struggle to charge a Bluetooth earpiece. This is a company that has received at a minimum $1.1 million, and quite possibly tens of millions of dollars. And 2 years after their big fundraising push, they continue to receive more money from governments and other institutions. And at best, they've been able to produce a turbine that can't even charge a cell phone.